this session where we are going to discuss today the top DevOps interrogation which are frequently getting asked in all the interviews. These are the questions you can refer if you are fresher or even if you are having the experience in the DevOps area. These questions will be generally asked for all level of the candidates. Okay, let's get started with the question number first question. So the basic thing is, what is the DevOps? So we heard this DevOps as a buzzword a lot of time, and and we do work in the DevOps area as well. But this is a very generalized questions. So actually, DevOps compromise of a development and the operations. It brings people, process, and technologies together to continuously deliver value to the customers. So most of the companies have different teams, dev teams, QA teams, ops teams, right? But the DevOps concept is where you have one team which will do the development, testing, and the operations. And operations involves all kind of deployments, automated deployments, and even the support to those deployments even after the deployment to make sure it is working uptime 100% and reliably. Second question, what are the different types of EC2 instance based on their cost? So this is, as you understood with respect to EC2, it is this is question of AWS cloud, and we have three types of instances in the three types of EC2 instances. The first one is on-demand instance. These instances are prepared as and when needed. So whenever you want, you can just go to the AWS console and you can create what kind of AWS instance you want, of what type, what configuration. You can just go and create it. Second types are the spot instances. These type of instances can be bought through the bidding model. So AWS has their own quota about all the instances, what different number of instances they support. Suppose there are instances got unsold, and those are ideal with only AWS. AWS allows you to bid on those instances on a cheap rate, so you can get spot instances of high configuration even in the cheap rates. Reserved instances on AWS, you can create instances that you can reserve for a year or so. So if you have a requirement where you want to have an instance at least for a 1 year or 2 year or 3 year, and you don't see there is a chance you are going to stop that and or terminate that instance, you can go for reserve instance, and that will save you a lot of cost. There are different pricing model with the reserve instance, like you can build the upfront, you can build the partially upfront, and depending on that you can get more discounts on the reserve instance. Okay, what do you understand by the VPC? So we know that whenever we work on any cloud, we have the different terminology on different clouds, but on the AWS we used to call it as a VPC, a virtual private cloud, and it is a network that actually logically isolated from the other networks. So in one AWS account in one region, you can create the multiple VPC. Okay, there is obviously a soft limit by the AWS, but we can increase that to create how many VPC we want. And two VPCs, suppose if you have two VPC in one region, in one account, those two VPC are actually private to each other, and those can be operated isolated within keeping in the same region as well. It allows you to customize your networking configuration, like what kind of IP range we want for that VPC. So whatever the instances we create in that VPC, those will get the IP range from that CIDR block of the IP range. It also allows you to have your private IP addresses, like I just mentioned, internet gateways, subnets, security groups, etc. All other features of the VPC. Okay, what is the relation between availability zone and the region? So like we know, AWS has multiple regions, and you can choose a region which is closest to you to get a minimum latency. So if I'm residing in the India, I can choose the Mumbai as my region, where I can get the minimum latency to my application, so that end users will not feel any latency while accessing the application. So AWS has a separate geographical areas. Those are called as regions, like US West 1 or the Asia South. So we have like, Australia, Germany, Europe, UK, Canada, Montreal. So we have the different geographical areas where AWS has their own data centers, and from there we can create our AWS resources into specific regions. On the other hand, availability zones are the areas that are present inside the regions. So let's take an example of the Mumbai. Okay, so Mumbai has a 3 availability zones. That means Mumbai. So whenever you try to create any instance in the Mumbai region, it will either go in one of these 3 availability zones as A, B, C, and those are the actually private, AWS private data centers, and separated by the geographical distance. So we'll be having a 3 availability zones. That means 3 data centers in the Mumbai region itself. So whenever if there is a one data center goes down, there is always other twos are keep running, and that's how you can design your application architecture to make sure 100% uptime of your application. These are generally isolated zones that can replicate themselves whenever they're required. Okay. How can you add existing instance to new autoscaling group? So autoscaling is a one feature in AWS, and where we can create one group, and we can give some kind of configuration like what are the minimum instances we required, what are the maximum instances we required, and what is the threshold criteria where we can do the scale in or scale out of the instances. And that way, we can use whenever there is a high load is occurring on our application, we can increase our EC2 instances, and we can make a horizontal scaling for our application. So this is a very simple steps. I will just read out what are the different steps. So you can go to the EC2 console, select your instance, and choose the actions, instance settings, and then attach the existing autoscaling group. So if there is no autoscaling group already existed, you can just say new autoscaling group, which will create a new autoscaling group for you, and you can attach this group to your instance. Then you can edit the instance if you need it. For example, what kind of configuration for that instance required. And once done, you can successfully add the instance to the new autoscaling group. So that way, we can have a autoscaling. We can create a new autoscaling group through the instance screen itself. What are the types of load balancers? So load balancer is a very generic term, right? And in any application design, it carries a very crucial role with respect to directing the traffic and all the load to your different applications. So in the AWS, we have 3 types of load balancers. First is an application load balancer, second is a network load balancer, and third one is a classic load balancer. So network and classic are so classic load balancer is a very old one, and AWS suggests that you should not go to the classic load balancers. You should either use a network or the application load balancer. Network load balancer is works on a layer 4, which is on network 4, layer 4, and application load balancers works on the layer 7. Most of the time, whenever we want to route a traffic, depending on the host base or the path base, we should use application load balancer, because that provides the natively support for these kind of functionalities. Network load balancers are good when you want a static IP, you want a very high throughput, you don't want to worry about how the routing is happening. You can just route all your traffic from the network load balancer, from the network layer itself. Then in that case, network load balancer is a very good option to choose. Mention some of the core benefits of the DevOps. So we see what is the DevOps in the first question. So what are the different core benefits of the DevOps, and we can take a leverage of it. So technical benefits, obviously we can do the continuous software delivery. There will be less complex problems to manage because of DevOps. Early detection and fast correction of defects. That's what we call as a fast fail. If it is going to fail, it should fail fast, so that we can get to know at earlier, and we can fix it before it is damaging the more application. Sorry. Business benefits. On the business side, faster delivery of the features. We can use the pipelines, so that whenever there is code gets merged, it get automatically deploy on your cloud. That way we can achieve a faster delivery. We don't need to, being it is automated, we don't need to worry about the manual errors as well. Stable operating environments. So being it is automated, we can do most of the things automation. With automation, we don't need to worry about human errors. Improved communication and collaboration between the teams. So earlier the teams are working in the silos, and they used to pinpoint on all the bugs or whenever there's some situation happen. But with this DevOps, we can have across the teams or within team, the communication and collaboration can be increased to perform more. Okay, what is the infrastructure as a code with respect to the configuration management? So, sorry. So infrastructure as a code itself, tells us what it depicts, right? So whatever the infrastructure we required, for example, EC2 instances, RDS instances, load balancer, target grows, all these infrastructure requirements can be handled writing a simple code using there are various tools to write such code. And the benefit of it, that you don't need to worry about what are the steps you need to follow. So code will obviously follow always the steps. It will check if that resource is already created. If not, it will create automatically. So you don't need to worry about a large systems where there are hundreds of resources are getting deployed. And if you want to replicate that to the other environments or maybe other region, you just need to rerun your code, and it will create all the resources automatically, considering all the dependencies it requires. Okay, so writing code to manage configuration, deployment, and automatic provisioning, managing data centers with machine-readable definition files rather than physical hardware configuration, and ensuring all your servers and other infrastructure components are provisioned consistently and effortlessly. Administrating cloud computing environments, also known as infrastructure as a service. So we can use it, to check all the state files, all the existing state of all your resources, and we can monitoring as well. We can just administrating as well our cloud resources. Explain the difference between centralized and distributed version control system. So whenever we consider any source code, and there are multiple people working on that source code, we have to have some, source code versioning system. And there are two types of it. One is a centralized and one is a distributed version control system. The centralized version control system is, all file versions are stored on a central server. No developer has a copy of all the files on a local system. If a central server crashes, all data from the project can be lost. The example of this centralized version control system is a Git. We use Git in most of the current existing version systems like GitLab, GitHub, Bitbucket. All these are using a centralized version control system. The backend is a Git. Distributed control system, every developer has a copy of all versions of the code on their own system, enables team members to work offline and does not rely on a single location for backups, and there is no threat even if the server crashes. So the example is, the VCS or the CVS we used to have earlier days. Those are the example of the distributed control system. Okay, what is a Git stash? So suppose a developer is working with a current branch and wants to switch to another branch to work on something else. The developer doesn't want to commit changes because that work is not completed. And how he can do it, then he can reserve his unfinished work in a stash for some time, and he can continue working on another branch, and then he can again do the Git stash pop, and he can continue on the unfinished work without losing any of his already done work. So that is what Git strategy is giving in a nutshell. Okay, the concept of the branching in a Git. So I used to ask this question most of the DevOps candidates. So we all use the Git, but how to use Git effectively, that will come how you decide to do the branching strategy in your Git system. Suppose you are working on an application and you want to add a new feature of the app, a new feature to the app. You can create a new branch and build a new feature on that branch. By default, you always work on the master branch. So you take the new branch from the master branch, you will work on your feature, and you will again merge it into the master. The circles on the branch represents various commits made on the branch, and after you are done with all your changes, you can merge it with the again master branch, and master branch can be used to deploy your code to your servers. What is the difference between git merge and git rebase? Suppose you are working on a new feature in a dedicated branch, and another team member updates the master branch with the new commits. So you can use these two functions so that you will not be having any conflicts. So first is a git merge. To incorporate a new commits into your feature branch, use a git merge. It creates an extra merge commit every time you need to incorporate changes, but it pollutes your feature branch history as well. So the second option is to do the git rebase. As an alternative to merging, you can rebase the feature branch onto the master. So what it will do is it incorporates all new commits to the master branch in the master branch, and it creates a new commits for every commit in the original branch and rewrites the project history. So that way your Git history will not get polluted. Okay, on the Jenkins pipeline side, there will be a couple of questions now. So explain the master slave architecture of the Jenkins. Sorry. Yeah. So Jenkins master pulls the code from the remote GitHub repository every time there is a code commit. So if we have webhooks associated with our GitHub and the Jenkins, whenever there is a code push on your repository, Jenkins can trigger its pipeline. It distributes the workload to all the Jenkins slaves. And on a request from the Jenkins master, the slaves carry out builds, test, produce test reports. So just as an example, let's assume that this is my Jenkins master, and we can have multiple slaves. I will say one is as my Java slave, one is my .NET slave, right? And what the use of these? So suppose I have hundreds of projects running on my Jenkins master, and it will take a time, so Jenkins master will have some kind of capacity limit, right? Let's say it's of 4 GB RAM and 2 core machine, for example. It will be get exhausted having a multiple pipeline, right? Multiple jobs in a queue, and to finish that queue, it will take a lot of time. So what we can do is we can introduce a different slaves, and on this Java slave, for example, I will install a JVM. On this .NET slave, I will install a .NET engine, right? So that it will build all the .NET projects, and Java slave will be responsible to build all the Java projects. And in that way, we can, in our pipeline or in our Jenkins job, we can mention any project where it should get executed. And this way we can divide the workload from the master branch. And this will turns out, the faster processing of your jobs queue. Okay, moving to the next one. What is a CI/CD? So CI is nothing but continuous integration. And it's something that is used for streamlining the development and deployment process. These lead to the more rapid development of cohesive software. So I have a team of 5 people, suppose, and everyone is merging their code. Everyone is building on different feature. They are merging their code, but there might be possibility that one person code might depending on another person's code, and while building a new feature, it might breaking the other features. So continuous integration will help us that my compiling, my project building is happening consistently whenever someone is pushing the code, and whatever the code I have in my master branch is intact, compilable. Continuous delivery on other hand is the process where your code after being pushed to remote repository can be taken to production at any time. So uh, whenever we build a code and we get some kind of package out of it, for example, in case of Java, let's suppose we are getting the jar file. Continuous delivery is a task where we'll put that jar in Artifactory so that whenever we want to deploy on any production environments or any other environments, we can use it, that jar from the Artifactory, and we don't need to rebuild the whole project again. CD means as well as a continuous deployment. I forgot to mention over here, but continuous deployment is where we do the continuous integration, we do the delivery, and we take the next step as a continuous deployment as a part of the Jenkins job itself. What is a Jenkins file? So Jenkins file is nothing but as a text file, and it contains the definition of a Jenkins pipeline and is checked into the source code repository at the root level most of the times. It allows code review and iteration of the pipeline. It permits an audit trail for the pipeline, and there is a single source of truth for the pipeline which can be viewed and edited. So whenever we create any Jenkins job, we can have we don't require to create a job in a Jenkins itself, but we can mention a Jenkins file in our repository, and whenever if there are any changes required in our Jenkins pipeline or Jenkins job, we can make those changes in our Jenkins file, and which can be checked in into the source repo, so that it can use the new features from the pipeline whenever the code is getting pushed. So that way we don't need to worry to back up our Jenkins job. What are the ways in which build can schedule and run in the Jenkins? So there are many ways. So by the source code management commits, for example, like we saw in last one of the questions, where we can engage the GitHub webhook in the Jenkins. So whenever someone push the code in a GitHub, my pipeline will get triggered automatically. Maybe it can act as a downstream build where after completion of any other build, my job should get started. A schedule to run at a specific time, just like a cron job. If you want to get my test cases executed every 2 hours or every 1 hour or every 5 minutes, we can schedule in that way. Or one may can choose to trigger it manually in case of the production releases. People used to trigger the build manually to deploy on the production environments. What are the features of Ansible? Ansible is a configuration management tool, by the way, and it will be helpful, and it's very easy to learn as well. It will help you to configure any application on remote server from one of its Ansible node. The benefits of using Ansible and the features are as following. Agentless. Unlike the Puppet or Shape, there is no software agent managing the nodes. So we can only have a Ansible node where we have installed Ansible, and we can execute all the scripts from that machine itself. We just need to give the domain names or IP address where we want to execute all the tasks. Python. So it is built on top of Python, which is very easy to learn and write a scripts, and one of the robust programming languages. Though actually creating Ansible scripts, we don't require to know the Python knowledge. But if we want to customize any module, we can use the Python to write easily a new custom module as well. And Python is mostly installed on most of the instances, and it is easily available to set up the Ansible and Python on any machine. SSH, so passwordless networks authentication, which makes it more secure and easy to set up. So the connection to the remote servers can be happened through the SSH protocol. The mechanism is a push mechanism. The core concept is to push multiple small codes to configure and run the action on the client nodes. On respect to the setup, this is very easy to set up with a very low learning curve, and any open source, and it is also open source so that anyone can get hands-on. Manage inventory. Inventory is nothing but the machine address where you want to execute the your task. So machines addresses are stored in a simple text format, and we can add different sources of a truth to pull the list using the plugins such as OpenStack, Rackspace, etc., or the AWS Cloud, etc. Okay, what is the role in Ansible technology? So Ansible role is independent block of tasks, variables, files, and templates embedded inside a playbook. So you can just consider, if you are familiar with the general coding concepts, as a functions, right? So we can consider functions as an Ansible role, where we can group all together and we can execute this package wherever we want. For example, if I want to set up a Jenkins using the Ansible, for example, I can have all the tasks related to the Ansible, setting up the Java, setting up Jenkins, executing the Jenkins binary, configuring some plugins. All this can be packaged, and I can share this Ansible role or package, to the other people so that they can just invoke this role from their task, and that way they can set up a Jenkins without knowing much detail on the Jenkins workings. What are the key features of the Terraform? So Terraform is a tool or technology, we can say, for the infrastructure as a code, and it helps us, to provision the resources on different cloud platforms, or even on the on-premise platforms as well, with VMware, etc., to provision the new resources. The main features are a console that allows users to observe the functions, the ability to translate HCL code into the JSON format, a configuration language that supports interpolation, and module count that keeps a track of the number of modules applied to the infrastructure. So whenever we apply the Terraform plan, or we plan what kind of changes we are going to make on the cloud, we will get a plan first, and we will make sure that it will give us confidence that whatever changes we are going to do, whether those are correct or not. Okay, the Docker. So Docker, you might have heard the word Docker. So Docker is something which is a container technology, and you can build images and create a containers using those images to run your applications. So architecture of the Docker. So Docker uses a client server architecture. Docker client is a service that runs a command, and the command is translated using the REST API and sent to the Docker daemon, which is a Docker server. Docker daemon accepts the request and interacts with the operating system to build the Docker images and run Docker containers, like I said earlier. Sorry. And Docker image is nothing but a template of instruction which is used to create a containers. So we can, so let's take an example. I want to create a container of a Java application where I will mention some instructions like, use a Ubuntu image, install a Java JVM, and then copy my jar file into that container and run that jar file at the end. So whenever we create a container from such image with this instruction, all the time it will make sure that it will have a isolated Ubuntu mini OS inside the container, and it will install the Java and run your jar file over there. Irrespective whether your machine is a Fedora or your machine is on SUSE Linux, it will not matter. Docker container is an executable package of an application and its dependencies together. Docker registry is a service to host and distribute Docker images among users. So to share such kind of images, we can build up or we can set up a Docker registry, and where we can upload the Docker images so that others can use it. Just like what we have for source code, source sharing, a Git kind of stuff, we will have a Docker registry to save our Docker images. What is a Dockerfile used for? So Dockerfile is used for creating a Docker images using the build command. With the Docker image, any user can run a code to create a Docker containers. And once the Docker image is built, it is uploaded in a Docker registry. And from the Docker registry, users can pull the Docker image or get the Docker image and build a new containers whenever they want. What is the purpose of expose and publish commands in a Docker? Okay. Expose is an instruction used in a Dockerfile. It is used to expose the ports within a Docker network, and it is the documenting instruction used at the time of building an image running in a container. Expose is the command used in Docker. For example, expose and your port number. As example, expose 8080. So if my application is running on the port 8080, we can give a command in a Docker file as expose 8080, and that makes sure when you run the container within a Docker network, it will run on the port 8080. And you can do this port forwarding, and you can access it from your local browser as well. But that is the use of the expose command. Okay, the next term is a publish, and publish is used in a Docker run command. It can be used outside the Docker environment. So if you see, expose can be only used within a Docker network. However, publish can be used outside the Docker environment as well. It is used to map a host port to a running container port. Whatever port we get from the expose is the container port. Publish or -p, publish or -p is the command used in a Docker CLI. So for example, Docker run -d, -d means running as a daemon, -p to publish the port, and we're exposing the containers port 80 to your localhost port 80, and then you can give your image name over as a last parameter as well. What is a container orchestration? So consider a scenario where you have 5 to 6 microservices of an application, and now these microservices are put in individual containers, but won't be able to communicate without a container orchestration. So as an orchestration means all these instruments playing together in harmony in music, for example. Similarly, so the container orchestration means all the services in individual containers working together to fulfill the needs of a single server. So whenever we talk about the microservices, right, we need to consider the communication between how the microservices happens. So orchestration tools like Dockerfile or OpenShift or Kubernetes, they provides you a service feature where you can expose your service microservice, and they can talk to each other. They are allowed to talk to each other, as well as the overall the pods or containers spinning, how they should spin, when they should spin, where they should spin. All this care taken by the container orchestration tools like Kubernetes. Okay, what is a Kubernetes? Kubernetes is an open source container management tool that holds the responsibility of container deployment, scaling, and descaling of the containers and the load balancing. Being a Google's brainchild, it offers an excellent community and works brilliantly with all the leading cloud providers. So we can say that Kubernetes is not a container platform, but it is a multi-container management solution, or we can say it's a container orchestration tool. How is Kubernetes related to the Docker? So like you see, Docker is one tool which builds the image, and out of which we can create a container. Okay, and Kubernetes will manage its life cycle. It will manage the container's life cycle actually. Okay, so it's known fact that Docker provides the lifecycle management of the containers, and Docker image builds the runtime containers. But since these individual containers have to communicate, Kubernetes is used. Docker builds the containers, and these containers communicate with each other via Kubernetes. So containers running on multiple hosts can be manually linked and orchestrated using the Kubernetes. What is a kubelet? This is an agent service which runs on each node and enables the slave to communicate with the master of the Kubernetes. So kubelet is a part of the Kubernetes, and this service will run on all the nodes of the Kubernetes cluster, and it will enables all the slave machines or all the worker nodes to communicate with the master machine. So kubelet works on the description of containers provided to it in the prod spec, and make sure that the containers described in the pod spec are healthy and running. So Kubelet will keep checking the health of the all the running pods on your worker node. What are the Helm charts? Helm charts is used for combining all the Kubernetes YAML manifest in a single package, which can also be advertised to our Kubernetes cluster. Once we install all the Helm chart in our cluster, it is easy as running as a one single Helm, and that simplifies the deployment of the containers application. So if you see, Helm chart is nothing but you can consider as a packaging material for your all the Kubernetes manifest or all your Kubernetes applications. You can, if you want to deploy the same application on multiple environments with a different configuration as well, Kubernetes Helm charts deployment will be very beneficial. With these Helm charts, you can package the core manifest, and you can pass on all these configuration variable, all the configurations as a variables while executing the chart. That way, your deployments or your manifest don't need to change per environment. Those can be templatized, and variables can be passed so that we can achieve the maximum benefit out of it. What are the concepts used in the Helm? Okay, so the first concept is a chart. It's a package consists of the pre-configured Kubernetes resources. Release, it is an instance that can be deployed to the cluster with the help of the Helm. And repositories, it is a group of all the charts that are available for others. Just like we see the Docker registry and the GitHub for the source. To maintain the all Helm charts, we can have a Helm repository, and where we can push our Helm charts, or we can access the others Helm charts created by others, accessing the Helm repositories. Okay, so this question is related to SRE, site reliability engineering, and the question is, what is MTBF and MTTR? So SRE. Okay, before proceeding to on this question, SRE is something where SRE engineers are meant to look after the reliability of your site or your application and its uptime, its reliability overall. So they need to calculate different metrics and make sure that they can present to the managements or other clients, so that they will get out of it what would be the impact on the clients of that outage or something like that. So MTBF is mean time between the failures, is the average time between repairable failures of the technology product. The metric is used to track both the availability and reliability of the product. The higher the time between failure, the more reliable the system. So if there is a huge time between two failures, that means our availability of the application is more, and it is not failing frequently. That means, in other words, MTTR, mean time to recovery or mean time to restore the broken application. It is the average time it takes to recover from the product or system failure. This includes the full time of the outage, from the time system or product fails to the time that it becomes the fully operational again. That's the MTTR. Okay. And the question is, what is the difference between the DevOps and SRE? So in general, whenever a term DevOps comes up, people have lots of misconception around it. For example, DevOps is something, people do Linux administration, people do only deployments, people do only specific thing, but in general, DevOps is a lot more than that. And SR is a different stream from the DevOps itself. So it is a scale out from the DevOps. So overall, DevOps is something, where you can design and, architect from what is a Git branching strategy to the what is your monitoring strategy for your application after the deployment. And SR is something, how can that monitoring and observability can be reliable so that, we will have the high MTBF or, high time or 100% uptime of your applications. So this is reducing the organization silos. SRE treats ops more like a software engineering problem, and DevOps focuses on both dev and ops departments to bridge these two worlds. And leveraging tooling and automation perspective, SRE is focused on embracing consistent technologies and information access across the IT teams, and DevOps focuses on automation and the adoption of technology. Okay, with this last question, okay, there's one more point with respect to this difference and measuring everything. DevOps is primarily focused on the process performance and results achieved with the feedback loop to realize the continuous improvement. So how can we improve our process next time from the last learnings? That's all about the DevOps. Whether it is a requirement gathering using the Jira, whether it is our Jenkins pipeline, whether it is a monitoring system, it is DevOps is all about getting the feedback and improving it more from the last state. SRE requirements measurements as well of SLOs as the dominant metrics, since the framework observes ops problems as a software engineering problems. So we'll see how many failures, what are these failures, what is the pattern, so that we can make sure it will not happen again, and we do the required meetings so that we will not encounter such kind of problems again. All right, with this, we have covered all our questions. Thanks for joining us. Have a good day.